Okay, it's time. Ahoy Vjishny. My name is Nikita Lipsky, and today we will talk about Jigsaw Layers. So when I was at Java 2017, I visited quite a lot of sessions about Jigsaw from creators of Jigsaw. Mark Reinald, Alex Buckley, and almost any session was ending with the questions about versioning, such as why Jigsaw has no versions, when Jigsaw will have versions, or how can we live without versions. There was no clear answers on those questions, and the most direct answer on the question when Jigsaw will have versions was never, without any explanations. Honestly speaking, it is not easy to give an answer on those questions on a questions and answers sort of a session. So I decided to give a detailed answer why Jigsaw has no versions and what it has instead. But who am I? I have 20 years experience in the JVM and compiler development under Excelsior Jet project, where I did many things. For instance, I authored Java runtime slim down technology that was Java SE split into components that was available to Excelsior Jet users since 2007, 10 years before Jigsaw release. I have joined Huawei this summer to work on Huawei JDK experimental setup enabling ahead-of-time compilation. Okay, so what we are going to talk about. First, the disclaimer, it's not Jigsaw introductory or review session, so I expect that you already know some Jigsaw basics. But anyway, in the beginning, I will give a very short introduction to Jigsaw for you to understand the contents of this talk. So, in the beginning, we will talk about jar hell problem and versioning as a solution to jar hell problem. Then we will talk about problems with versioning, and then we will talk about Jigsaw layers and how they can help to solve the jar hell problem. And in the end, I will have some live demo and a bonus track. So let's start. So any module system is all about import and export. Module import something and export something. Extremely easy concept, easy as apple pie. And modules in JPMS are described in source files called module-info.java that should be in the root of your source root directory. So modules become a part of your source code base and not some external metadata. And imports are described with requires keyword and modules imports modules. And modules can export packages with exports keyword. And modules can also provide and use services. Once import and export is resolved, modules form so-called modular dependency graph. So why may you need modules? Jigsaw highlights two main benefits that sounds like a mantra. And to sing that mantra, I need to take an appropriate pause. So the mantra is reliable configuration, strong encapsulation. So what does a reliable configuration mean? It means that all modules, the Jigsaw guarantees that no required modules are missed in your final configuration, and there are no cycles in the dependency graph, and there are no split packages. We will talk about split packages later today. Strong encapsulation means that everything that is not exported from your module cannot be accessed from outside even via reflection. So you are free to change your implementation details, being not afraid that someone outside relies on that implementation details. And that's all that I wanted you to give as introductory to Jigsaw. Modules are really a simple concept. It's import, export, dependency graph, and we are done. But anyway, even with this basic information, we can now pose the problem that we are going to fight during the session, the jar hell problem. So the jar hell problem is most easily illustrated by the following example. Suppose your app depends on a library foo. that depends on a library bus of some version. At the same time, your app depends on a library bar that also depends on a library bus, but of a different version. If you put both versions of library bus on the class path, it becomes unclear what version will be loaded. At runtime, the most probably one version will partially overwrite another one, leading to unpredictable program behavior at runtime. And to solve this problem, Jigsaw module might have a version in the first Jigsaw drafts. So import and export was qualified by a version in Jigsaw. So if two modules require two different versions of one library module, both versions will be loaded. However, versioning was removed later. You may ask, why? Okay, let's discuss. First, let's think how to implement versioning. So the problem is, for a given module A, importing library lib of version v1, and module B, importing library lib of version v2, it is required that both versions of lib work without conflicts. And to solve this problem, Java had class loaders feature since day one. So class loaders provides unique class namespaces. So a single JVM can load two classes with the same fully qualified name, provided that they get loaded by different class loaders. So if each module is loaded by its own class loader, the classes of one module won't conflict with classes of other modules. And the case when two different versions of the one library are loaded by JVM becomes resolved. So we have quite a clear problem and quite clear solution. So why not just implement it? What's the problems? So let's continue. Okay. Okay. Can you hear me? Okay. Do not breathe. So in general, when trying to solve oh, sorry. In general, when trying to solve the versioning problem, we will inevitably at some point come to a concept that each module should be loaded by its own class loader. And it was exactly so in the first Jigsaw drafts. However, let's remember that Jigsaw is not just modules, but also Java SE platform split into modules. By the way, Jigsaw had been developed for 10 years, not without reasons. One of the main reasons was that it was really hard to split that monolith called RTJAR into well-defined modules, with well-defined dependencies without access, cycles, and so on. Fortunately, this job was done, but JDK developers faced with serious problems when trying to, during this work regarding versioning and Java platform split into modules. And for instance, according to the Java platform specification, all core platform classes should be loaded by so-called bootstrap class loader, that is JVM internal class loader that does not have an instance. So get class loader for core platform classes must return null. And it efficiently precludes the splitting of the platform into modules, where each module would be loaded by its own loader. You will laugh, but the fact that some misconceived could be unavailable in JDK 9 is not backward compatibility issue, because Java specification never claimed that that you must have that class, but it claimed that get class loader returns null for core platform classes, so changing that behavior would have violated backward compatibility directly. Backward compatibility is still holy cow for Java. JDK developers work really hard to keep invariant that everything that guaranteed by a Java specification of older version is satisfied for a newer version. That's why if you run your application that runs on some older Java version, it should run on a newer version, okay. If, of course, if your application does not have some unspecified reliance, some reliance on unspecified behavior of a particular Java SE version. Oh, sorry. Sorry. Moreover, many class loaders for platform modules may also bring backward compatibility for your own application. For instance, your application may have your own class loaders that the most probably had standard application class loader as a parent class loader. And now, if platform modules would be loaded by separate class loaders, what should you specify as a parent class loader for your own modules? For your own class loaders. And even the fact that application class loader does not extend URL class loader anymore causes problems. Once creator of Async Profiler, Andrei Pagin, tweeted, ironically, even official Java 8 demo from Oracle, Java to demo, does not work on JDK 11. And the problem that one of Java to demo class tried to cast application class loader to URL class loader. However, it is not backward compatibility problem from JDK point of view, because JDK specification never claimed that application class loader must extend URL class loader. So it's a classical example of application reliance on unspecified behavior. But anyway, you may face with similar problems when trying to switch to JDK 9+. Now let's understand if versioning really solves the jar hell problem. So here's our favorite feature with jar Classpath Hell that we would like to solve with versioning. So what does the fact that an app requires a module of two different versions mean? It means that if the first version has a class A, then the second version may also have a different class A. Now, what does the fact that the module foo imports module buzz mean? It means that it can use our first class A. And the same holds for the second class A. And what does the fact that app imports module foo means? It means that it can use any classes of module foo that in turn may use our first class A. And thus, our first class A appear in the namespace of our module app. And the same holds for the second class A. And now, here we can watch the following dialogue between them. First class says, I am A. Another replies, no, I am A. And everything blows up, of course. It can be demonstrated by the following. So what I would like to say, the JVM specification defines so-called loading constraints that prohibits two classes with the same fully qualified name to appear in the namespace of another class. For instance, in this example, if class B is loaded by L1 class loader and class A is loaded by L2 class loader, then the JVM will check that T1 class is the same for both class loaders. If it is not the case, the JVM throws Java linkage error. And the problem is not rare. Everyone who plays with class loaders faces with this problem sooner or later when two different classes with the same name start meeting. So we can conclude that versioning does not actually solve the jar hell problem, but it raises to a new, more sophisticated level instead. And there is one more detail. Import in early Jigsaw drafts was qualified not by a single version, but a version range. So a module could declare that it can work with several versions of one dependent library. By the way, I have found how versions could have been described in early Jigsaw drafts. Here, my module of version 1.0 imports module lib module from versions 1.2.3.1 to 4.0. Little bit weird syntax, isn't it? So why version ranges were important? It is known that if a module can work with some major version of its dependent module, then the most probably it can also work with some newer version of same module. And if we would stick dependency requirement to particular version, it would bring too excessive rigidity to the system. So the case when two versions of same library appear in the final configuration would take place quite often. And version ranges could soften the problem in great extent. And a prototype on all of this was written, and JCK standard tests were written on all of this. And I remember very well how Alexei Shepelov told me that once a JCK engineer wrote a test that passed half an hour on quite powerful Oracle workstations. Then he submitted a bug performance report to the GeeCON team. Your resolver resolves too slow. And when GeeCON team started to fix that issue, it turned out that resolving dependencies from version ranges is an complete problem. It's simply reduced to 3 sets. What does it mean? It means that Jigsaw resolver can resolve dependencies forever. And after that, versioning in JPMS breathed its last. Jigsaw architects could not allow to introduce in JPMS something that could lead to potentially infinite startup time, of course. And if there is no versioning, there is no need for class loaders for modules. And if there is no class loaders for modules, we don't have class loaders violation problem, no backward compatibility problem, because the set of standard class loaders remains the same, and the resolver became much, much easier. So all problems were solved, except the original one. So how to solve the jar hell problem now? Okay, first, this situation is simply prohibited by Jigsaw. Two different versions of one module just won't get into JPMS, which is good because you recognize the problem right on application startup and not at a runtime at an unpredictable point, provoking you to waste a lot of time in debuggers. But you may ask, stop, Jigsaw doesn't have versions. How it can detect this conflicting situation? And here we can note that the most probably two different versions of same library have same packages. And Jigsaw prohibits for two modules to have same packages that are called split packages. Okay, that's great that Jigsaw can detect this conflicting situation. But how to solve the jar hell problem after all, if we face it with it during development? And now let's remember again about backward compatibility. So Java, as a platform, has backward compatibility feature. And it is naturally to expect that libraries that are written in Java also follow the backward compatibility rule. So if you face with this situation, it sounds reasonable to resolve it by choosing the newest version of a conflicting library. But unfortunately, libraries are not always backward compatible in reality. So it may happen that library foo does not work with newer version of library bus. Then you can try to switch to a newer version of library foo that works with a newer version of library bus. And playing with the dependencies such a way, you'd probably find a suitable configuration that works. However, if you have a really big application where dependency graph looks like on this picture, playing with the dependency such a way may not work so good. Remember, dependency resolution problem is NP-complete. And trying to solve this problem manually can make you really sad. So to solve this problem, developers invented another way that works even on the class path. And the way is to relocate classes of a conflicting library to different packages. However, this solution may not work again because Java has reflection. And reflection is not always loyal to class relocations. So there is one more solution, to employ class loaders. So if you move conflicting versions of two different class loaders, we can solve the problem. You can write such class loaders by yourself or use a framework from small one to big ones that will do it for you. However, I don't suggest you to overuse this approach, else you will need to fight with the class loader constraints violation problem. And even if framework you choose to address this problem somehow, you will have hard time of refactoring your dependencies once different classes with same name start meeting. And here we come to culmination of the session. Yes, we will talk about Jigsaw Layers later. So yes, the first solution for resolving the jar hell problem is to employ Jigsaw Layers. So what is the Jigsaw layer? A layer in JPMS is essentially a local module system. When I told you that split packages are prohibited in Jigsaw, I was a bit incorrect. They are prohibited within one layer. But if two modules with same packages belong to different layers, then Jigsaw does not treat it as a conflicting situation. Jigsaw itself defines so-called boot layer. It contains core platform modules loaded by the bootstrap loader, platform extension modules that are loaded by platform loader, and your application modules loaded by application loader. And your application, at any time, you can create your own layers. And the split packages are prohibited within one layer, but different versions of same library can belong to different layers. For instance, here we see that Hadoop layer and JavaScript layer contain different versions of Guava and Jackson. Fortunately, pointer is not shown here. Okay, and as we see different versions of the same library, it becomes interesting to know how layers are implemented from the inside. And of course, they are implemented via class loaders. Each layer has at least one unique class loader, may have several class loaders like boot layer. And here we can exclaim, what? So what about class loader constraints? Won't we have exactly the same problems that we could have with versions? And actually not, because class loader constraints are impossible to violate by construction of Jigsaw layers. Let's understand why. So here's our favorite picture with jar hell. And Jigsaw suggests to solve it by moving your application modules to separate layer. The most probably it would be just boot layer. And modules that cause version conflicts are moved to separate layers as well. So the problem seems to be resolved. However, I feel that it is not everything okay with this picture. Let's play a game. Who will see more differences between these two pictures? What differs in these two pictures, except that we see that the big green boxes run small ones? Who can tell me? Yes, arrow's direction. Yes, the arrow direction from A to B means that A imports B. So app imported foo before, and now foo imports app. That's it. What does it mean? So every layer in Jigsaw has a parent layer. And modules of child layer can import modules of parent layers. However, parent layer modules cannot import child layer modules. And that's why it's impossible to violate class loader constraints. Let's recall how it got the class loader constraints problem. So we had two different classes with the same name that were able to meet, moving by dependencies downside up. However, here we see that arrows go in opposite direction. So these two different classes A have no chance to meet. And now we can hear a completely different dialogue between them. Audio? No audio. Oh, I can sing. There is a space between us, a place that I can't go. Who knows Carole King here? No one? Okay, let's go further. So looking at this picture one more time, we can come to a question. Okay, if application modules cannot import child layer modules, then how they can employ functionality implemented in those child layers? And here we can be rescued by the well-known design pattern called inversion of control. Who knows the inversion of control pattern here? Who doesn't know? Okay, 2 people. Okay, so the idea of inversion control pattern is as follows. If we need some functionality for implementing some other functionality, then instead of importing that functionality explicitly, we can declare an interface. I need the functionality by the following interface. And someone outside implements that interface and injects that dependency into your class. It can be done manually by passing interface implementation as a parameter to constructor of your class, or it can be done automatically by using dependency injection frameworks such as Spring or Juice. And in an inversion control design pattern can be used in Jigsaw as well by using native Jigsaw mechanism called Jigsaw Services. So yes, modules of parent layers can't import modules of child layers. However, child layer modules can provide services to parent layers. Let's look at our picture again. So here we see that library foo imports our module app. It's nonsense, of course. Library modules can't import application modules. To fix this picture, we need to add a bit of code of our own application to each of separated layers that from one hand would import our libraries and on the other hand will provide services to our main application modules. And it is the right picture that really solves the jar hell problem. So here the theoretical part of my session comes to end. So now let's talk about practical aspects of the subject. So how can we use layers within our applications? And today layers are created by programming code. That code is very declarative, so one can imagine a framework that would create layers by some configuration metadata. But I'm not aware of such frameworks. By the way, I think it's a good idea for an open source project. So we need to create layers manually now. And so to create a layer, first we need to tell Jigsaw where are your modules located. It is done via creating module finder object. Then we need a parent layer. In most cases, it will be just boot layer. Then we need to resolve dependencies within our modules. It is done by creating a configuration where we pass our module find and a set of root modules to start resolving dependencies with. And if we succeeded with creating configuration, we can create a module layer with a parent layer, just created configuration, and a parent class loader that will be used as a parent class loader for module layer class loader. And finally, we can get services provided by the layer, just created layer, using service loader. And now it's demo time. Why did it isn't shown on the screen? Sorry. So how can we fix it? That's why. I don't know. Huh? No, it's not my slide. I would like to show ID, but I can't do that. No, I don't know what the reason is. No one can help me. No technical guys? So maybe I would like to show presenter view in my IDE and now. I don't know how to do this. Yes. And I just changed to, or moved to IDE. I don't know. I can move from here. You see it? Okay, great. Superman, yes. So here we have a very simple application that collects Java conferences around the world. But it collects not by itself, by using so-called Java conf provider interface. That looks the following way. It just provides a conference by a string. And it is a module. It has the following declaration. So it exports everything. It exports our Java conf provider and use all its implementations. And if we run, and the application takes all implementations of Java conf provider and outputs what they provide on the standard output. And if we run our application now, we won't see anything because there are no implementation of Java conf provider. So let's add some. So let's add GeeCON Prague provider. So it looks, it simply implements our Java conf provider interface and provides string hello from GeeCON Prague. It is also a module. We can see its module declaration. It just provides Java conf provider as a service. And if we now run our example, so what's happened? Okay. Well, we won't see anything else. Okay. So what's happened? Control Z. So we won't see anything again because our main module doesn't know anything about just edit module. So to fix that problem, we need to add our GeeCON provider module to the dependencies of our main module. So let's edit. Okay. And we need to mark that module as runtime. Mark that dependency as runtime dependency, else we will have cycle between those two modules. And now let's run our example. Okay, we see now hello from GeeCON Prague. Let's now add some other implementation. Let it be GeeCON Krakow provider module. So GeeCON Prague provider looks very similar to GeeCON Prague module. It has exactly the same fully qualified named class Java conf provider impl from package or GeeCON, but has a different implementation. Now it says hello from GeeCON Krakow. And we also need to add the dependency to the list of dependencies of our main module. And we also need to to mark it as a runtime dependency. And if we now run our example, we see Java-lang layer instantiation exception. Actually, these modules looks very similar. They have exactly the same class inside with the same name, but we have two different classes. So we have just simulated our jar hell problem, and Jigsaw was able to detect this conflicting situation. It sees that OSGi is in both modules, GeeCON Prague provider and GeeCON Krakow provider. So now let's try to resolve this problem by moving with Jigsaw layers. And we will move GeeCON Prague provider to a separate layer. For that, first we need to remove that dependency from our module path, from dependency of our main module. Okay, and now we need to write a bit of code for moving the GeeCON Prague provider to a separate layer. And here we have a method create layer where we pass a location of our module and its name. And what we do here, everything that I've already shown you on slides, that we create module finder object, we have parent layer, and we create configuration, and finally we create a layer. I pass here to that module, or to that method location of our GeeCON provider module as the first argument of our program. It can be seen here. So it's just a location of a GeeCON Prague provider on the disk. And once we have a layer, we can get all services it provides, all JavaCon provider interfaces. As our boot layer is the parent layer of our just created layer, and we have GeeCON Krakow in the boot layer, we have GeeCON Prague in just created layer, so we now service loader should return both implementations from our layer. And if we now run our example, okay, we see both modules, we see both implementations. So we have just solved our jar hell problem with Jigsaw layers. Congratulations. And now I will need to to return to my presentation. Oh, it works, but only for one direction. Great. So we have just seen a very simple console application, but in reality, Java is used mostly on the server side. However, on the server side, we have a problem. That application servers today aren't aware of Jigsaw. So if you deploy a server-side application to a web application server, you just cannot tell that application server where are your modules. What does it mean? It means that I cannot benefit of Jigsaw anyhow on the server side. No reliable configuration, no strong encapsulation on the server side. It's because even the servlet container standard knows nothing about modules so far. And dependencies in WAR files are all plain class paths, in fact. And I thought that we should not give up. Actually, all that modern application servers are open source. So we can fork our favorite application server, adding a Jigsaw layer into its web application class loading logic. And I did it with Tomcat server, and I would like to share the results with you now. First, let's understand how class loading works in Tomcat. In fact, Classpath of Tomcat contains a small jar called bootstrap.jar that creates a class loader for the rest of Tomcat jars. Then Tomcat creates a separate class loader for each web application that is deployed on Tomcat. And since Java 9, a class loader can assign a module for a class it loads. But if it does not do that, all its loaded classes will belong to so-called unnamed module, even if classes formerly belong to a named module, to a jar that with module -info declaration. And it can be demonstrated by the following example. I have created a classical modular hello world example that contains two modules. One provides hello world string and another outputs the strings on a web page. And the module also outputs a name of two modules of loaded classes on the web page. And if we run the sample on the usual Tomcat, we will see that, that modules of both classes have no name. So the classes belong to unnamed module. However, if we run the example on my fork, we will see module names. And now I'm going to tell you how I achieved this. So in order to achieve this, I had to add a modular layer to Tomcat class loading logic. So first I had to tweak class loading logic of Tomcat itself. Before my patch, Tomcat was loaded by a simple URL class loader. I created a modular layer with Tomcat jars with the code that is very similar that I've shown you on slides before. Then I had to tweak class loading logic of web applications deployed into Tomcat. Tomcat loads classes of web application from two places, webinf/classes and webinf/lib, of a WAR file, web archive file. I left those two places intact and introduced the third place that I called webinf/modules. Here I create a layer with jars from webinf modules. And I use Tomcat modular layer as a parent layer of a new layer. So the depth of our layer hierarchy becomes 3. Then I use the layer for loading web application classes. And as a result, I've got the modules and their names at runtime, and achieved Jigsaw enlightenment. However, you may say that Tomcat is yesterday. All we have Spring Boot microservices today. May we have any problems with Spring Boot if we would like to use it with Jigsaw? And the answer is yes, of course. So if you deploy your Spring Boot applications as an executable jar, then your application classes will be loaded by Spring Boot application class loader that, of course, knows nothing about Jigsaw. So you won't have modules with Spring Boot as well. However, actually, we can launch Spring Boot application without Spring Boot application class loader, putting all external dependencies just on the class path. And this way, we can modularize our Spring Boot application using standard migration path for modules. That is, we put everything on module path first, and then we add module declaration for our own modules. However, there is one Spring-related problem with this migration path. Spring looks for bin definitions scanning the class path. So if we put everything on module path, it won't just find anything. However, Spring is open source again. So we may tweak its class path scanning logic to work with module path as well. And if we do that, we may also fix the problem with one jar deployment via forking Spring Boot class loader and adding a modular layer into it. So that's all for today. Let's sum up what we have learned. So in the beginning, we talked about versioning. And versions for modules look like a good idea, but there are many problems with them. There are certain problems with backward compatibility. It's hard to use versioning safely because of class loader constraints violation problem. And NP completeness on dependency resolution is just a showstopper for them to appear in the Java standard. On the other hand, Jigsaw layers allow to solve jar hell problem safely because no class loader constraints violation by construction of Jigsaw services or Jigsaw layers. And Jigsaw services help employing functionality implemented in a child layer from a parent layer. And the knowledge about the layers can help in modularizing of Java applications, including server-side applications. Дякую за позорность. What else? Questions? Okay. Maybe have we some live questions? Okay. There is a question on Slido. Adding layers seems to be dynamic, so you might have some problems during runtime. Okay, it's an interesting question. Jigsaw modules was thought from the beginning not as a dynamic framework, but a static framework. So we have modules before execution, actually. So every GDK tool, so many GDK tools knows about modules. Java-C knows about modules. So when you access some not exported functionality from one module to with another module, Java-C will just say that it is not good. It will issue an error. And if we talk about Jigsaw layers, actually some static properties are also satisfied for Jigsaw layers as well, because when you architect your modules that you will then bring to some separated layer, anyway, you have some import, you have some export, and this import as export is checked on the build time as well. So here, but of course, Jigsaw also has modules at runtime, and it has modules at runtime even if for module pass and for Jigsaw layers as well. So yes, you may have problems, but at least all the problems will be if problems with modules that are put on module pass exist, they will be detected just on application startup. And if some problems with the layers, with modules that you put on the Jigsaw layers exist, they will be reported at the time of creation of layer. Yes, at some point later. And it is the difference, yes. So thank you for the question, who asked it. A few more. Wow. Was it any good reason to have Jigsaw? Layers are just plain old class loader. Not layers. Thank you for the question. All my talk was about telling you that layers are not old class loaders, because when you have class loaders, you will need to fight with that class loader violation problem. And it's a really serious problem. With Jigsaw layers, they thought so roughly to avoid that problem. So it's a really safe way to resolve the jar hell problem that can't be solved by plain old class loaders. Yes. You, of course, using layers, you can't export, you can't use any types of child layers from parent layers, because they don't import child layers. So, of course, you need to architect your application. If you need to wrap somehow types introduced in child layers in a main application layer, and yes, but you your architecture will become cleaner after that refactoring. I think because you mastering everything using one business model of your main application. And I think it's good. Your architecture becomes cleaner. Syntax for layers in module info. Yes. Layers are just a separate mechanism. You create layers with programming code, as I said. But all your modules should be described with module minus info as usual. It just can be put to Jigsaw layers. Did I answer the question? How far is Spring with adoption? Spring 6, as far as I know, introduced, at least it introduced automatic module name for all its modules. And Spring is designed very good in terms of Jigsaw because all modules of Spring has no split packages, and at some moment Spring can be modularized, and they have an issue to modularize it at some point. So I think they will do it. They had some problems with tooling. Now, because they need to be compatible with Java 8, and there was no simple tools for making Java 8 Java 8 compatible artifacts. But with modular declaration, now that tools appear, so they, as far as I know, they don't have any technical problems for modularizing their jars. But of course, maybe they don't have enough time for doing that. But I don't know. So maybe in a year or two, they will fully modularize Spring artifacts. But let's see. But they also need to think broader, because they need to solve class path scanning problem for Java 9 plus, because they scan Java class path. They don't have a mechanism for scanning module path, and maybe they need to tweak their class loader as well for you to have modules at runtime, even with deploying your Spring Boot applications as single artifact. But all the problems are solvable. They can do it at any time. So let's see. Oh, so as I see, no more questions? And no more time. So thank you for your attention.